Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P1549, indicates a high voltage issue within the charging system of the Honda Accord models from 2012 to 2017. This often points to a malfunction in the alternator, which plays a crucial role in generating electricity to charge the battery and power the vehicle's electrical systems. The alternator is usually located near the front of the engine, driven by a belt connected to the engine's crankshaft. If the alternator fails, or if there's high voltage output, the vehicle's onboard diagnostics will flag this code, prompting further investigation. Diagnosing the issue correctly involves checking freeze frame data, which holds essential information about the vehicle's operating conditions at the time of the fault. It's also important to verify if any high-voltage battery, like a hybrid system, is connected, as this can trigger DTC P1549 erroneously. Understanding and accurately diagnosing DTC P1549 is crucial for maintaining the vehicle's reliability and performance. In summary, DTC P149 signifies a charging system high-voltage issue primarily linked with the alternator's function. Proper troubleshooting involves several steps: verifying the fault, replicating the conditions to check for error codes, and addressing the alternator or electrical connections accordingly. Following the repair, it's crucial to perform a verification process, including resetting the PCM and conducting an idle learn procedure. Regular preventive maintenance will help ensure this issue doesn't recur, including inspections of the alternator and electrical wiring. Understanding and addressing DTC P1549 in a timely manner can significantly improve the Honda Accord's reliability, ensuring the vehicle operates seamlessly and efficiently. DTC P1549 represents a high-voltage problem within the charging system, primarily associated with the alternator's performance. The alternator is crucial as it provides electrical power to the vehicle and charges the battery while the engine runs. Should the alternator output exceed acceptable voltage thresholds, this DTC is recorded. The alternator is typically found mounted at the front of the engine, making it accessible for inspection, but still requiring certain disassembly for replacement. In addition to the alternator, wiring and connections surrounding it should also be inspected, as they can contribute to inaccurate voltage readings. Understanding the role of the alternator in the charging system is critical for effective troubleshooting of DTC P1549. Several factors can lead to DTC P1549 being triggered, with the most notable being a malfunctioning alternator. If the alternator is producing voltage above the acceptable range, that is a likely cause. Moreover, poor electrical connections can lead to erratic voltage readings. Corroded or damaged wiring may disrupt the current flow. Loose terminal connections can also hinder the alternator's ability to function properly, leading to high voltage outputs. It is essential to inspect all associated wiring and terminals closely during diagnosis to eliminate these potential issues. This systematic approach will ensure the underlying cause of the high voltage error is accurately identified and resolved. When DTC P1549 occurs, the driver may notice various symptoms that indicate charging system issues. A primary symptom is the activation of the battery warning light on the dashboard, which alerts the driver to potential electrical problems. The vehicle may also experience malfunctions in electrical systems, such as dimming headlights or power windows that respond slowly. Performance inconsistencies can also arise. For instance, the engine may hesitate or struggle to maintain speed under load, as insufficient battery charging affects engine performance. Recognizing these symptoms promptly can aid the driver in seeking immediate assistance and prevent further damage to the vehicle's electrical system. It's important to understand that these symptoms are interconnected and usually indicate an issue in the charging system or battery health. The first step in troubleshooting DTC P1549 involves verifying the problem accurately. Start by turning the ignition switch to the on position, or pressing the engine start-stop button to activate the electrical systems. Next, it's essential to clear any existing DTCs using the Honda Diagnostic System, HDS, ensuring a clean slate for further testing. After clearing the codes, start the engine to prepare for subsequent checks. This initial step is crucial because it establishes the baseline system state and confirms the presence of a genuine fault. Ensuring that no extraneous error codes are present helps focus on the current issue more effectively. In the second step of troubleshooting, it's vital to check specific conditions to replicate the fault accurately. Before proceeding, ensure that accessories such as the air conditioning, headlights, and rear window defogger are all turned off. Holding the engine speed at 3,000 RPM without any load, meaning that the automatic transmission must be in park or neutral, will allow for a controlled environment during testing. This approach helps isolate the charging system's performance by eliminating other electrical loads that could produce misleading data. Monitoring the system for any pending or confirmed DTCs through the HDS during this step provides insight into whether the previously logged issue persists under test conditions. Upon analyzing the results from the previous step, it is crucial to determine whether DTC P1549 is still present. If the code appears as a confirmed DTC upon testing, it indicates that the issue has been replicated, and the next step is to replace the alternator. Replacing the alternator is important, as it is likely the component responsible for the high voltage condition. Conversely, if DTC P1549 is not indicated, it may imply an intermittent failure, in which case the electrical connections should be inspected thoroughly. This includes checking the alternator's terminals and the underhood fuse relay box for any signs of poor connectivity, such as corrosion or loose connections, that could have contributed to the issue. Once the alternator has been replaced or the electrical connections have been repaired, it is critical to perform a final repair verification. Start by turning the ignition switch to the on position once again to prepare for the system checks. Next, reset the powertrain control module, PCM, utilizing the HDS tool. This clears any stored faults in the system and helps recalibrate any relevant parameters. Following the PCM reset, conducting an idle learn procedure allows the vehicle to adapt to the new component and ensures it runs efficiently. This step is essential, as it helps the vehicle's control systems recognize the proper parameters for operation with the new alternator or corrected connections, thus securing reliable functionality. Preventive maintenance is key in avoiding issues like DTC P1549 in the future. Regular inspections of the alternator can help detect potential flaws before they escalate into significant problems. Checking the wiring and associated connections periodically is equally important, as corrosion or wear can compromise performance. Ensuring that connectors are secure will facilitate stable electrical flow and maintain proper voltage output. Monitoring the overall health of the electrical system, including battery condition and performance, will provide invaluable insights into the vehicle's charging system. Ignoring these maintenance steps could lead to unexpected failures and costly repairs down the line, emphasizing their importance. Please like and subscribe to the channel. See you next time.